Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering in Institute of Aeronautical Engineering, Hyderabad. In this video I'm going to discuss about the essentials for problem solving. So in this one, I'm going to first discuss about the graph terminologies. So the very first thing is that, so what is the graph actually? So graph is nothing but a data structure. So that consists of set of nodes, what we call it as vertices, and set of edges that relates the nodes to each other. The set of edges that describes the relationship among the vertices. And a graph is going to be defined as follows, like G equal to V comma A, where V is nothing but set of vertices and E is nothing but set of edges. Uh, so what can able to call it as V of G, that should be a finite non-empty set of vertices, and E of G is nothing but set of edges, what we call it as a pair of vertices. So graph is nothing but a data structure that consists of a set of nodes, what we call it as vertices, and set of edges that relate to nodes to each other. And these set of edges going to describe the relationship among the vertices. So normally this graph is going to be defined as follows. So G is equal to V comma A. So V of G is nothing but a finite, a non-empty set of vertices, and E of G is nothing but set of edges, what we call it as a pair of vertices. So examples of graphs. So let V be the set of vertices 0, 1, 2, 3, 4, and E is nothing but set of edges. What can able to write it as 0, 1, 1, 2, 0, 3, 3, 0, 2, 2, and 4. So here what I can able to say that is uh, so here the vertices is 0, 1, 2, 3, and then 4, right? So these are the set of vertices, and edges may be 0, 1, 1, 2, 0, 3, and then 4. So this and all what we called as a edges here. Okay, so when xy is an edge, so we can able to say that x is an adjacent to y and y is adjacent from x. So 0 is adjacent to 1 and 1 is not adjacent to 0 and 2 is adjacent from 1. So this like this we are going to be differentiating the edges here. There are two types of graphs what can I able to call it as directed graph and undirected graph. So in undirected graph, we should not have any kind of arrows. In directed graphs, we are going to have an arrows. So if you look at this diagram, so UV, so there is no arrow mark, so this thing should be treated as undirected edge. So if I'm going to convert the edge with an arrow mark like this, so this should be called as a directed edge. So in undirected edge has no orientation, no arrowhead, and in direct edge has an orientation, what we call as arrowhead. An undirected graph is going to have all the edges are going to be undirected, and directed graph all the edges are going to be directed. So these are the different types of directed graphs and undirected graphs. So undirected graph has how all the edges are going to be directed, and in directed graphs all the edges are going to be directed, whereas in undirected graph all the edges are undirected. So here in undirected graph should have no orientation, whereas the directed edge is going to have arrowhead. So let's see this graph. We're going to have a graph like this in which each edge carries a value. So here, uh, instead of this, I'm going to take another example like so A, B, C, D. So this is the undirected graph. Suppose if I'm going to convention like this arrows, so we have an edge from A to C, not from C to A. Similarly, I have edge from B to A, not from A to B. Okay, along with this, I'm going to represent the weights in the graph. So how much weight is that? So in weighted graph, if I'm going to have some weights along the edges, then it should be treated as a weighted graph here, and weighted directed graph as well as weighted undirected graph also there. So a graph which is in which the edge carries a value, that should be treated as weighted graph. So let's see example like directed graph. So in directed graph, so the edge is an incident to vertex j and an incident from vertex I. So that means in directed graph, and directed edge is nothing. It is an incident to vertex j and incident from vertex I. And similarly, the vertex I is adjacent to vertex j, and vertex j is adjacent from vertex I. So these are the conventions we have to be follow in directed graph and undirected graph. So when it comes to the graph terminology, so here the adjacent nodes. What is the adjacent nodes here? So the two nodes are said to be adjacent if they are connected by an edge. So the two nodes are said to be adjacent. So if I'm those nodes are going to be connected by an edge here. So that means the 5 is adjacent to 7, or 7 is adjacent from 5. And next one is that path. So what is the path here? So path is nothing but a sequence of vertices that connect two nodes in the graph. And simple path is the path in which all the vertices except possibly the first and last are going to be different. And the complete graph, so a graph in which every vertex is directly connected to the every other vertex. So the first one is that adjacent node. So the two nodes are said to be adjacent if they are connected by an edge. And path is nothing but the sequence of vertices that connect two nodes in the graph. And path is the simple path in which all vertices except in first and last should be the different one. And complete graph is the graph in which every vertex is directly connected to every other vertex. And next one, what is the cycle? So cycle is nothing but a simple path, so with the same start and end vertex. So the degree of vertex I is the number of edges incident on vertex I. So in this diagram, if I'm going to see, so what is the degree of 2? So degree of, there should be two things. So since there are these connected by two edges, so this should be treated as degree of this node. Similarly, if I'm going to consider 5, so the degree 1, 2, and then 3. So this is the degree of 5 is 5, 3. What is the degree of 3 here? So only 1. So that should be treated as degree as 1. So the simple path is the cycle is nothing but the simple path which has the same start and the same end vertex. And the degree of vertex is nothing but the number of edges that is going to be incident on vertex I here. So what is connected, strongly connected and weakly connected graphs? So undirected graphs are connected. So if there is a path between any two vertices. So if there is a, this is a considered as a uh, vertices. So if there is a path between the two vertices, then the two vertices are the two paths are to be called as a connected graph. Similarly, directed graphs are strongly connected if there exists a path from one vertex to the other vertex. And directed graphs are weakly connected if there is a path between the two vertex, ignoring the direction here. And complete graph has an edge between every pair of vertices. Uh, so here what I'm going to say that is, so The directed graphs are going to be connected strongly if there is a path that exists from one vertex to the another vertex. So this is a directed graph. If there is a text is there, then it should be strongly connected graph. An undirected graph are said to be connected if there is a path between the two vertices. And weakly connected means if there exists a path between two vertices ignoring the direction. And complete graph has an edge between every pair of vertices. And next one, loops. So what is a loop? So edge that connect a vertex to itself is called a loop. So if I'm going to have a vertex, the edge which connects to and same vertex it we call it as a loop. And path, so path is nothing but sequence of vertices and such that every adjacent pair of vertices are connected by an edge. So A and B are this, so this is the path, but every pair of vertices are connected by an edge is nothing but a path. And simple path is the path which all vertices except possibly the first and last should be the different one. So simple path means so path from A to B, B to C, and C to D. A simple path in which all vertices should be included, so except that the first and last should be the different one. And multiple edges. So multiple edges means if I'm going to have a graph, uh, the two nodes are going to be connected more than one edge. So this thing what we called as multiple edges. And simple graph is the graph which does not have any kind of uh, loops and then edges. So simple graph does not have any loops and multiple edges. This should be called as simple graph. And this should be called as complex graph. And this one called as multiple edges. And this one called as loops. And this one called as path from A to B or B to C like this. And next we will see about the graph properties. So in that one, the number of edges in the undirected graph. So what is the equation for that? So the number of possible pairs in a vertex graph is that n into n minus 1. So the number of possible pairs in a vertex graph is given by n into n minus 1. Since the edge uv is the same as vu, so the number of edges in undirected graph is given by n into n minus 1 by 2. So the number of edges in undirected graph I want to find out. So the number of possible pairs in vertex is given by n into n minus 1. That means 1, 2, 3, 4, 5, 6, 7, 8, 9. N is number of vertex is equal to 9. So 9 into 9 minus 1, 72. And the number of edges in undirected graph is given by n into n minus 1 by 2. So 9 into 9 minus 1 by 2. So 9 into 8 by 2. 36 edges. So how we're going to calculate the number of edges in directed graphs? So the number of possible pairs of n vertex graph is given by this one. So since the edge is not same as we use, so the same equation is going to be considered in directed graph as well, and the number of edges in directed graph is given by n into n minus 1, not n into n minus 1 by 2 in case of undirected graph. So in directed graph it should be n into n minus 1 only. So the number of edges in directed graph is given by this. So the total number of possible pairs in vertex graph is given by n into n minus 1. And since the UV is not same as VU, so the number of edges in directed graph is given by n into n minus 1. And the number of edges in directed graph is this one. So what is this in degree and out degree? So normally degree should be considered as the number of edges connected to the vertex is considered as degree here. So again the degree of vertex is calculated into two types like in degree and out degree. What is this in degree? In degree is nothing but the number of edges incident. So that is number of incoming edges. So if I'm going to take 2, so in degree of 2 is what is the only one, and in degree of 8 if I'm going to take, so there is no incoming edge, and out degree of 8 is 2. There are 2 edges that are leaving from 8 that should be treated as out degree, and the 2 edges that is so what is this, in degree of 6 is 1, 7 is 2. So out degree of 7 is 2. So the number of edges incident to I, so that should be treated as in degree. So the number of edges incident from I to I and from I, so that should be treated as out degree. That means simply if I want to say that is, so the number of incoming edges should be treated as in degree and number of outgoing edges should be treated as out degree. And graph representation, for the graphs we are going to have computationally useful and they should be more convenient to present in programs. So the two computer representation of graphs is that, so adjacency matrix representation and adjacency list representation. So what is this adjacency matrix representation and adjacency list representation? So if I'm going to have a graph like this, adjacency matrix representation, I'm going to consider the vertices like this: A to B 1, A to C 1, A to D 0, B to A 1, A to B, B to C, and B to D 1, C to A, C to D, remaining zeros, and D to B, D to C, remaining all zeros. So this should be called as adjacency matrix. So normally the graph representation should be done in two ways, so adjacency list and adjacency matrix. So these are the two computer representations of the graph. And adjacency matrix, a square grid of Boolean values is going to be considered. If a graph contains n vertices, then the grid contains n rows and n columns. For two vertices numbered I and j, the element row I and j is true if there is an edge from I to j, otherwise it should be false. So an adjacency matrix is a square grid of Boolean values and which is going to have n vertices, and then the grid contains n rows and n columns. For two vertices numbered I to j, so there should be edge from I to j, otherwise false. So this is the adjacency matrix representation. So the vertices are going to be constructed along this rows and columns. If there is an edge from 0 to 0, I'm going to write it as false. Otherwise, if there is an edge from 0 to 2, so that's why I'm going to write it as true here. So simply another example I'm considering. So 1, 2, 3, 4, 5. So in 1, 2, 3, 4, 5, what I'm going to do that is, so there is an edge from 1 to 1 that should be treated as 0, 1 to 2, so S, 1 to 3 exists, 1, 1 to 4, 1, and 1 to 5, 0. So again 2 to Z 1, no. So there is an edge from 2 to 1, right? So I have write 1, so this 2 should be 0, and 2 to 4, so there is an edge from 2 to 4, that's why I'm writing as 1 here. So like this we are going to write down the matrix, what we call the adjacency matrix. So what is about adjacency matrix in case of directed multigraph? So in directed multigraphs, so the edges should be treated as 1, 2, 3, 4, 1, 2, 3, 4. So there is an edge from 1 to 3, so 1 to 2, so 3 edges are there, so 3 I'm writing, and 1 to 4, so only 1, so I'm writing as 1. Similarly from 2 to 0, self loop, so self loop 1 is 1, and 2 to 3 there should be 2, so 2. So like this we are going to consider the adjacency matrix in this one. And next one is adjacency list. So in this adjacency list representation, a graph of n nodes is represented by one-dimensional array of linked list. So where L of I is the linked list containing all the nodes and adjacent from node I, and the nodes in the list of I are in no particular order. So graph of n nodes is represented by one-dimensional array of linked list, where L of I is the list containing the nodes adjacent from I, and nodes in the list are known but no particular order. So consider an adjacency list. So for every vertex V, it should belongs to V, which is going to be a set of vertices. And what is the adjacency of 1? So that should be 2, comma 3. So for 1, the adjacent elements will be 2 and then 3. And for 2, adjacent element is only 3. And for 3, there is no adjacent element in terms of directed graph. And 4, the adjacent element is 3. So how much of storage is required here? So the degree of vertex is equal to incidence edges, and the directed graph has in degree and out degree. For the directed graph of items in adjacency list, the out degree should be written as modulus E, and for undirected graph also the degree should be written as 2 into modulus E. So the adjacency list is going to take as V first meta V plus C. So implementing graph. So how going to implement the graph? So what are the vertices is there? So that should be taken along this rows and then columns. And if I'm going to map P to P, that's thing, so it should be 0. And if there is an edge from P to R, so exists, correct. And P to W will also be 1, so remaining all are false. And similarly for 0, that should be 1. So I'm writing as, so for Q also I'm writing, so if there is an edge from Q to X, so Q to X there is an edge, so I'm writing as 1. And next one is linked list, adjacency list, what we call. Suppose if I'm going to have a graph like this, so how can I able to represent the graph in the form of adjacency list? So this is the list header, so with set of vertices, and if there is an edge from A to B, and weight is 8, and from B I have no edge, so from again I have A to D, so A to D, so D cost is 6. And similarly from B, so what are the edges that are connected? A 8, and then B to C 9, and for C there is only B, so remaining it should be 9. So like this we are going to represent the adjacency list for the graphs as well. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.